Okay. Hello, team. We're gonna finish the CPU today for 100% absolute certain sure probably. Um, every time I start streaming, I'm always like so worried that I'm going to stream my credit card number. I don't know what that would look like. It's literally right here. But for some reason. Hi, Di. How you doing? Uh, absolute. Absolute index. Okay. So this is B9 is my current instruction. It is the absolute index with Y version of load accumulator. So we've got load A absolute. M subscribe, praise me. Yes, you are my first ever subscriber. So I apparently have become a a Twitch affiliate now. I didn't know how that worked, but apparently that's how that works. So that's pretty cool. Alright, so what goes on here? So we fetch the opcode, low byte, high byte, add index register to low byte increment PC. Wow, that's a lot going on right there. And then read from effective address, fix the high byte of effective address. And then reread from effective address? That's sort of weird. Oh, this will only be executed if the effective address is invalid during cycle 4, i.e. page boundary was crossed. Okay, so that makes sense. And we can probably just no-op that if we want to. Okay, what do I have available here? I've got read inc no wrap, which is probably not what we want. Increment PC. 100 bits. Diana, stop giving me money. What are you doing? Okay, how many bytes is this supposed to be? 3 bytes. So if we look at this, okay, so the increment PC is just the I had some left from the winter charity. Oh, all right, fine. Now you're the #1 bit person also. You have all of the badges. Okay, so this should actually be relatively easy. What we need to do... Where's the indirect X? I feel like that would also be helpful. Alright, so this always takes forever when I try to have to figure out the first thing. So what we want to do here is like index. Do I have like an index width? I do. What does that do? Index width. Oops, it's right there. Literally just adds it. So that's probably not good enough. Because what we need to do is like index and fetch. Alright, so let's just make an index and read. Index and read. Alright, and then we'll take index, which is right here. Index and read. And we'll do read and update flags. It's exactly the same thing. And then what we got to do... So, first of all, this pretty clearly needs 2 because you need to index it and then you need to load it somewhere. and then this is going to be toName, index name, toNum, toName as U8, index num, index name as U8. Let index reg cpu.getReg by number, index num, let toReg cpu get reg by number of reg num. You pass it in. Okay, so now that we have these two, what we want to happen in this cycle is, so we already fetched it, and then what we're going to do is we're going to do add index register to low address byte, fix high byte, read from effective address. And then we will add one and reread from the effective address if we need to. So, okay, read inc no wrap. Hey Organ Harvester, how's it going? That's a hell of a sentence, really. Okay, so we need like let temp abl equal cpu.abl as u16 plus index reg. How's it going, Organ Harvester? Having a good day? If temp abl is greater than ff u16, then cpu.abh plus equal 1 and temp cpu.abl is equal to, or no, cpu.abl is equal to temp abl as u8 unconditionally. Then, slowly hammering out thumb on my godforsaken emulator, but yeah, I'm doing good. Cool. Are you doing the Emerald Challenge? Okay, and then we want to do get loaded, and then we want to set toReg to loaded. Also, in this case, we're going to do cpu.q.push front micro fun no-op, and then we do that. Calculate this junk. I don't think this is possible, so we leave that alone. Okay, and so then the only difference here is that we're going to do index and read. Yeah, the 1 month one, doubt I'm going to make it in time. I've spent 6 hours staring at ARM disassembly, and all I have to so far is error core memory read on map read 32 at Zalgo. That sounds rough, man. Sounds like a real bummer. Okay, so, oops. Index and read. We're going to go to register A, and we're going to index with register Y. And then I need to add index and read here, and also up here. It's pretty obvious now, by the way, that the major issue with my current implementation, what? Oh, I must have changed it wrong. It's pretty clear now that the issue with my current microcode implementation is that I didn't write a way to pass stuff from one stage to the next, which is why I have so many bespoke, just slightly variant micro ops. So if I was going to do this again, that's what I would change. Oh yeah. Okay, abs. It's going to become, what's it called? Globals work wonders. Disagree. What am I missing? Oh, literally just forgot to put the Y on you. There we go. Go. Nope. Borrow checker. Why must you be so insistent? Is that better? Yep. Not putting it in the Mario Maker session based on a technicality. That would be funny. Hey, an attempt to add with overflow. I had this conversation once already. I know I did. I know I have this solved somewhere. CPU.abh. Okay, so this is what I did. Okay, there we go. Invalid instruction 19. Let's just go back and make sure that we did this correctly, because that was a new and somewhat weird instruction. What was I looking at? B9, I think. At DF60. So where was I? Dang, a lot of stuff happened. All right, B9, DF60. We start. We've got A0, X65, Y0, SFB. We know P is wrong. I really need to fix that at some point. Choo, decode F0. Okay, that looks good. And we got A is 89. Okay, looks like I did it right. Excellent. Granted, I haven't written an emulator yet, but if I did, I can bet I'd have a lot of globals. I mean, I give globals shit. It's not an unreasonable thing to do. It's not a very flexible way to go about it, but do what feels good, man. Do what feels good. All right, so aura absolute. To be fair, I have a lot of globals. They're just all constants, which is slightly different. I have the impression, perhaps incorrectly, that Rust would get very angry at me if I tried to do a bunch of global stuff. But I haven't tried to do a bunch of global stuff in a very long time, certainly since before I started writing Rust, so I could absolutely be wrong about that. So again, all I should need to do is add an index and read right here. Gonna read to A. Gonna index with Y. It would get very mad at globals. You need to put unsafe everywhere. Wait, what do you mean invalid instruction 19? Oh, I know what you mean. Underscore Y. All right, 39. It's going to be and, obviously. $39. And abs is just aura abs, but with and instead of aura. Wait a minute. I don't actually think this makes any sense. Hang on. Load A, abs Y. All I did was index and read. But that's not what I want to do here. I want to do like a fetch and index. Because if I try to do and, I'll do the and at the wrong time. Right? This like takes too long. So I think instead of index and read, what I really want is like a fetch and index. And then I'll read to A because that's what load A does. That makes a lot more sense. All right. Fetch and index. And we're going to look at fetch 2 by comparison. So I guess fetch and index only needs the index register because it's always going to fetch from the PC. Is that right? It's fetching from the PC, but it needs to add to the other one. So I mean, I guess it's always going to fetch to the... Alright, we'll do it this way. Oops, that'll go away. We get the index register value, right? We're going to fetch to ABH, which is this bit. Just gonna reg names ABH as U8. That's obviously a ridiculous thing to do, but that's what I'm gonna do anyway. Okay, so we fetch to the high byte of the address buffer. Then we do this junk to increment the address buffer. And then we don't do any of this because that'll be done by the actual opcode. So this fetch will give us the high byte of the address, and then we add to it. Right? That seems to make sense. Added to the 16-bit address from the instruction. Okay. And so now when we do load A absolute Y, what we are going to do is we're going to do fetch and index ABH, reg names Y, and then this is just going to be read 2. And for OR, do I have 2 copies of aura abs Y for some reason? Yep. Probably because one of them was going to be and. Alright. So similarly, fetch and index, reg names Y, and then aura. What does OR actually do? Read from the effective address and then do the thing. Okay, so that should work. And then same for and, fetch and index, reg names Y, get rid of U. Everything is terrible. What did I do wrong? No variant name, fetch and index. Okay, totally fair. Index and read becomes fetch and index, index and read, fetch and index, and that's it. Okay, go. Nope, still problems. Expected function pointer found closure. What did I capture by mistake? Oh, this should be 2 num. Expected struct vec found null. Oh, I probably just forgot a semicolon somewhere in here. Oh, yep, there we go. Okay, invalid instruction 59. Now let's just double check aura and anda because I had them wrong for sure. Okay, so DFAD. Choo. DFAD. Instruction 19 is aura, indirect y, or absolute y. A is 55, X is 39, 0, FB 46. Okay, and then choo. On the next instruction, which is B0, we have A is FF, X is 39. Okay, so that looks good. And then an AND is 39, DFD4. There we go. We start and we've got 55, 3B, FB. And then if we look at the next instruction, which is right here, DFD7, that's correct. 0, 3B, 0, C6. Okay, yep. All right. I am satisfied. 59 is Eeyore. Okay. Oh, wait a minute. That was weird. Wonder how long that was wrong. My confidence in NES test is just going down the tubes. I keep having mistakes that are just super not caught. What's the address? It's 59. Go. Okay, 79 is going to be add. ABC abs. It's actually using the right opcode, so that's good. ABC abs Y. Fetch and index. Reg names Y. Invalid instruction D9. Compare. Translate documentation to code. Fetch and index. Reg names Y. Go baby go. F9. Subtract. Carry. Oops, did it again. Fetch and index. Reg names Y. Go. Oh. Mobby. Go. 99. Store accumulator. fetch and index reg names y. Go. B4, huh? B4 is load Y, 0 page X. What? Interesting. So 0 page X is basically exactly the same, except that you do the adding on the first cycle. Address calculation wraps around if the sum of the base address and the register exceed FF, which probably will not happen with my fetch and index that I currently have, right? Because we do handle wraparound. So what we actually need to do is just duplicate the damn thing. Fetch, index, no wrap. Again, like, it's completely silly to have all of these things be just very slight variations on the same opcode, and if I had it to do over again, the way that I would resolve that problem is that I would allow passing instructions or passing information between the micro-ops, and then I could implement all of these as functions of each other, and it would work a lot better. But, you know, you win some, you lose some. LDY ZPG, do I have one of those? I do. LDY ZPG X is going to be B4 and the only difference is that we're going to do an X here, and we're going to do fetch index no wrap here, reg names X, and that should work. And then we need to do fetch and index. We just need to do this sort of housekeeping stuff. Fetch index no wrap, and then hopefully that's good enough. Go. Oh, nope, forgot to put it in at the beginning. Where are you? Oh, I did put it. Oh no, this is the wrong spot. Oh, okay, I see what happened. There we go. All right. Fetch index no wrap, and that should do it. Go. Okay, 94. So the one that we just added was B4. So again, let's take a quick look at this log here. And then compare to our output. This was at dbcd, which is a long way up, apparently. dbcd A6600. And then in the next operation, we read 10 dbcf 60A. Yep, looks good to me. Okay, so what's the next one? 94. 94. UR store Y. Okay. STY CPG X 94. X fetch index no wrap. Oops. Reg names X. Go. This code could be so much cleaner. Like, I like the general architecture, but there are definitely some things that could be a lot better. Oh well. maybe once I finish the challenge, I'll go through and clean up a bunch of stuff. All 0 page X indexes 15 or a ZPG underscore X fetch index no wrap fetch names X go. What? Go. Thanks everyone for showing up. I appreciate it. Really means a lot to me that you take time out of your no doubt busy days to stop by and see what's going on with me. I always want to encourage everybody to say hey in the chat if you're somebody who's new to the stream, especially. But if you don't want to do that, of course, that's also fine. I just like hearing from folks. Reg names X. Hi, Julio. Not sure how or if that's supposed to be pronounced, but welcome aboard. What brings you by? Where did you just kind of browse by on Twitch, or did you come here from one of the various places I posted this? Oops, 5. X index no wrap X. Just browsing before going to bed. That's cool. I'm happy that people are just sort of randomly stumbling into me, as opposed to everybody who shows up from the Emudev Discord. Not that I don't appreciate you guys showing up, but it doesn't feel as much like a victory, I guess, as organic traffic. Julio, are you a software person yourself, or just interested? Fetch next no wrap. X. Aw, Breadfish feels slighted. Sorry, Breadfish. You're my favorite N64 buddy. Comp ZPG. Hi, Serotonic. Thank you as well for stopping by. It really means a lot to me when folks feel that this is worth watching. Index no wrap. I don't know why I have to say that out loud every time to remember what it is. Saw you were working on an emulator and stayed because of the Rust. Hey, Rust Evangelism Strike Force. Yeah, Rust is my new favorite language, even though there are things about it that I would have done differently, but that's fine. I really like that it is an alternative language for writing C, especially on microcontrollers. Everyone who releases new languages seems to be really seems to be really focused on like, oh, I'm going to have a runtime, I'm going to be garbage collected, and that's just not an option on the sorts of microcontrollers that I used to write, especially in my former life when I was working on satellites. Those things are small and tiny and do not have a lot of space. I recently started diving into it, building a simple game engine using WebAssembly, but I'm still pretty rusty. Hey! I am interested to hear more from people doing what I think of as more performance-intensive tasks, like game development in WebAssembly, because WebAssembly, it seems very cool, but it also sort of just seems like the JVM. Like, we've had virtual machines before. The only thing that makes this one different is that it's on the web. Is that enough to like actually make it good in all the ways that we have struggled to make universal application development platforms good in the past? I don't know. It'll be really interesting to see. I hope to have an excuse to do some WebAssembly stuff at some point in the future. Maybe I'll try to port this to run on WebAssembly. I don't even know like how much is involved in that. Oh yeah, reg names x. Yeah, I'm skeptical of its performance, especially since there's so much translation between JavaScript and it. Yeah, I think. Well, I hope. Fingers crossed that will get better. I read the what do you call it? The like WASM interface types proposal thing, and that seemed like a decent way to approach it in the sense of making it ergonomic. But now, can you make it performant? Yeah, I recently saw that as well. Here's hoping. Yeah. That and the WASI stuff, the WebAssembly system interface, are both, I think, really interesting. Fetch, index, no wrap. Especially the system interface thing. I think that would be a really cool way to solve some of the problems that I see with Rust right now, which are mostly around like dynamic linking. It's not a super satisfying solution, but at least shipping stuff as WebAssembly and running it on an embedded runtime would be a solution for some subset of use cases. And it would make things like hot loading of code and stuff like that like a lot easier to do. It's not that it's impossible to do in native code. It would just be easier with some sort of embedded runtime. $76. Index, no wrap. X. I'm coming from the wild west of Node.js JavaScript, so I'm appreciating the structure of being able to develop in Rust. Oh yeah, if you're coming from JavaScript, I can imagine. Is Rust your first statically typed language? Or have you done some like C++ or Java or something like that before? I feel like, do most people still get Java in school? I know I got Java in school. Oops. It's been a couple of years since I was in school. First one I'm taking seriously, but I've done Objective-C and a little C++ in school. Okay, that's fair. Fetch, index, no wrap. Oh, I saw an error. What happened? Oh, maybe not. Okay. F6, increment memory. Boop. Index, no wrap. I gotta say, I'm really glad I decided to do the whole micro-op thing, even though they're not like the most perfect micro-ops that ever could live. This would be so much more irritating if I had to implement every single instruction from scratch. D6. Which names X. Index, no wrap. I went the other way from C++ to JavaScript. I love dynamically typed languages. I love that TypeScript lets me type as little or as much as I want. I find the idea of gradual typing seductive, but I have never used it in a way that I was happy with. But that being said, I've really only played with the Python implementation, and I hate Python anyway. Well, that's not fair, but I'm not a huge Python fan. So it is easily arguable that it was not the best of circumstances for me to flirt with gradual typing. I would love to see a dynamically typed language that also checked at compile time whether you were like doing something obviously stupid. And also one that requires you to actually declare variables. Those are like the two things I just really miss when I go from statically to dynamically typed languages. And that's painting with a pretty broad brush. Neither of those are inherent qualities of dynamically typed languages, but all the ones that I'm familiar with basically run that way. I feel like TypeScript would get you that. Maybe. I've never done TypeScript. I've never done JavaScript in any serious sort of way. I tried to learn JavaScript a couple years ago because I was having a hard time getting a job, and I thought that it would be relatively straightforward to get hired as a JavaScript dev because there seemed to be just a ton of openings in this area. But before I could complete my transformation, there we go. Before I could complete my transformation, I got a different job. So LDY absolute x is just exactly the parallel of LDX absolute y. Or LDA absolute y, I guess. LDY absolute x is BC. Whoops. LDY abs LDA abs y. Y. That doesn't do it. Flow and TypeScript are the two approaching to adding types into the JavaScript ecosystem, and I've only brushed the surface, but they let you do all the sanity checks at compile time, and then it compiles all the type information away and leaves plain JS for the runtime. That seems pretty sane to me. I mean, I don't really have any issues with JavaScript as a language. Well, I have a couple, but whatever. Every language has problems. But it does kind of seem like the ecosystem is a big issue for some folks. But yeah, that seems like a completely sane way to add static typing, and I bet you would get a lot of benefit out of it without losing the things that make JavaScript good. Instruction D3. Wait, what? Is there no instruction D3? Did I run off into banana land? Alright, what was the last instruction that I implemented? It was absolute X, so 1D. Stop being 1D, dang it. I'll scroll up. Decoded instruction 1D at E21A. Okay. A0, X79, Y54. Choo, and then the first thing you get is a 6, which is wrong. So I'm obviously fetching too many times. Where does this 6 come from? Oh, I'm fetching not enough times. Because it's not 0 page, it's absolute. I just wrote completely the wrong instruction. Oops. Well, at least that needs to get... No, it doesn't. There's no 0 page Y. Cool. Wait, I already have an aura absolute Y. What am I even doing? Aura absolute X. Yeah, I just had a total brain departure for a minute there. I don't know what I thought I was doing, but okay. Let's blow that away. X. X. Alright, it's done. Making it more difficult for myself. Okay, there we go. 3D, that sounds more sensible. So here's 1D. 3D is and. Okay. Abs X, 3D, and abs Y. Copy, paste, X, X. Wow, 20 whole viewers. That's pretty good for me. Not quite a record, but pretty good. Thanks for coming by, everyone. I appreciate it. Oops, that needs to be an X. Your abs Y. Literally just change the Y's to X's. There we go. $70. Add. There can't be that many more addressing modes, right? I gotta be almost done. Oops. Oh, I see. X. Choo. DD. Alright, so let's look at this. I did immediate, I did zero page, I did zero page X, I did absolute, I'm doing absolute X and Y, I did indirect X, I think I did indirect Y, so I think this might be the last one. There might be one more. Anyway, this is SBC abs Y becomes X. Wait, no, it might not actually be. No, it's compare. Okay. Comp abs Y becomes DD X. Boop. 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 There's probably a few weird ones too, like instructions that have different addressing modes. FD is going to be subtract. Yep. SBC abs Y. Oh, that needs to be an X. X. I was reading a blog post earlier today from someone who wrote a Game Boy emulator in Rust, and they were talking about writing like a little DSL to define microoperations, which sounded like a pretty cool idea. And I have mentioned a number of times that really a lot of this would be better done with macros so that I don't have a chance to screw it up. But, you know, absolute X. I am a tremendous idiot. Aw, don't be so mean to yourself. I'm sure you're only a regular-sized idiot. What's up? I forgot to initialize the fastmem pointer. Ooh, yeah, that'll not work. On what system? N64? I feel like you were doing N64 stuff, right? I also remember you saying, ain't nobody got time for that. I mean, I say that a lot. I say a lot of things. 3DS, okay, that makes a little more sense. I would like to see how bad fastmem on N64 would actually be, though. And by I would like to see, I mean, I will do that at some point. I think it would even work on Windows, like, most of the time, because almost nobody ever uses the MMU, is my understanding. And even in games that do use the MMU, like, who knows if they're using small pages or not? Not me, because I've never investigated it. What? Oh. That is a case, Nick, who is probably not watching, that actually would have been prevented by using an enum. Oops. My name actually has nothing to do with the N64, I just like the number 64. Yeah, I think I'm getting you mixed up with like Dude Joe or somebody because you have 64 in your name. Okay. Because I know we have somebody who's doing N64 stuff. 5e in the Discord. By the way, everyone, go check out the emulation Discord if you haven't, if that's not where you came from. It's pretty cool. There's some cool people there. The origin of me writing this emulator was a challenge issued from Psy in that Discord to implement a an NES emulator that could run Super Mario Bros. 3 in less than 2 weeks. You should post the link. You're right, I should. Let me do that. I should get one of those fancy schmancy bots that does stuff like this. Anyway, there's the link. I don't know if Velocity is gonna love me advertising that, but whatever. I don't think it matters. He'll probably be fine. It's a public link. Also to your YouTube if you want people to find it. Yeah, I should add that in the description next to my GitHub, but it's just A-Weigel. I mean, I'm A-Weigel everywhere. Google for me on all your favorite social media platforms. I'd be finishing my RDP if it sent triangle commands. Huh? I'm confused. You would be finished with it if it sent triangle commands? I understand the individual words, but not quite how they fit together. Sorry. 1E. Doodle-doo, doo. Do-do-do. The RDP, for those who don't know, is basically the graphics card of the N64. Wait, what? Oh. It specifically is the part that draws, just like draws triangles very fast. That's all it does is draw them and do a little bit of shading and stuff. But it's very fixed function as opposed to the RSP, which is programmable vector processor that looks a lot more like modern GPUs. Roar adds, oops. X, this is going to be 70. X. I meant I hit a brick wall since it doesn't receive any 3D commands. Oh, okay, so you can't implement your RDP because you have some other problem that is preventing the 3D commands from getting there. Alright, rotate left. Oops, too much grabbing. I really would like to work on an N64 emulator. I was like really jazzed about it for a while, and then some other stuff came up and got in the way, and then the fact that I'm working on this is making me a lot more motivated to try again. Dude, stuff is the worst. It is the worst. Hi, Nick. Did you see me shouting you out 2 seconds ago about how if I had just used the, whatchamacallit, enum, then I wouldn't have hit that bug? Did not. Yeah, well, you were right. I finally hit a bug that would have been prevented by just using an enum for all of these constants. I don't know why I didn't. I think I've been spending so much time trying to train myself away from how Rust, like trying to convince myself that Rust enums work differently than C enums, that I like can't use Rust enums as C enums. What the heck? Oh, there it is. My bad, decrement memory. It sends all the 2D commands fine and runs in spite of no 3D. Okay, that's cool. So that's interesting. So you're just never getting any 3D commands, huh? That's very strange. I have no advice for you because I haven't gotten nearly that far. Rust may get in your way a bit if when you want to cast the integer to the enum. Yeah, that is true. I mean, it's not like it's impossible to do. It's very easy, in fact, but it is a little bit more friction. Doodle-doo-doo, doodle-doo, doodle-doo, doodle-doo-doo. Valid instruction 04. Uh-oh. Is that not an instruction? C6BD, huh? Oh, okay. 2-byte no op, huh? That's these are the unofficial instructions, right? Yeah, because it looks like the absolute X is the last set of tests in the actual test, which is what I just implemented. So select is invalid ops, huh? Let's just let that run for a minute. Play. Oh, so these are the invalid operation tests, like that one, which jumped me exactly where I am now. Okay, cool. So now these are the unofficial operations. I don't know if I want to spend time on that, honestly. I mean, it wouldn't be that hard. But if it's not used by Mario 64, then or Super Mario Bros. 3, then what's the point? But you know what? Let's just keep going. Who cares? It'll be nice and easy. Alright, no op 04. So 04, obviously. No op, we're going to just fetch one, which does nothing, and then we'll have a no op. And then we'll do the same thing for 44. And for 64, four, 6, 4, 6. Gotta get going, but best of luck with your challenge. Thanks, Serotonik. Stop by again. I'll be streaming at least twice this weekend, if you have time for that. C6, C9. Will do. Awesome. Hope to see you then. 0C, A9, A9. No op, A9, A9 equals A9. Where's the... So this should talk about invalid instructions or undocumented instructions. Okay, so we're looking at what here? We've got 0C. which is an absolute addressing mode, basically. So it fetches twice, but then does nothing. Okay? Hello, Vilko. Welcome aboard. Thank you for stopping by. How did you come across our humble stream today? Did you come from one of the places I linked it, or just find it on Twitch? 14 is a no-op indirect X. There's a bunch of those. Just found on Twitch. That's awesome. That makes me really happy when that happens, because or is that a 0 page X? Whatever. I don't really expect it to, so it's cool when it does. Pretty interesting considering I barely understand what's going on. Cool. I mean, I'm glad that you decided to stop by. I'd be happy to answer any questions that you have if I can. Basically, what's going on is that I'm trying to write an N64, or not an N64 emulator. I've been talking about the N64, that's why I misspoke. I've been trying to write an NES emulator that is capable of running Super Mario Bros. 3 in, I was right, it is 0 page, in less than 2 weeks, per a challenge issued to me by someone on the emulation development Discord. Currently, I basically have finished the official opcodes of the CPU at this point. So in theory, it should run any official game, but there's a bunch of other opcodes that like do known things, which are not implemented yet, and so that sort of is what I'm working on here. When did I start? I started on last Saturday, so the 19th. So this is the 1 week mark, and I'll be done with the CPU today. 34, 54, 74, D4, F4, all are the same. Okay. Basically every 2, yeah. Or well, not. Okay. 30, 50, 70. 30, 50, 70. Yeah, so the last day of the challenge is the 1st of November. Pretty cool, man. Good job. Thank you. Appreciate that. It's been fun so far. I'm really enjoying it. Seven. This part is not super interesting, I'm sure, to watch, but, you know, whatever. D and F. I'm relatively new to programming. What language is this? The language is Rust. Uh-oh. What dumb thing did I do? The language is Rust, which is like a safe systems programming language. It's relatively new. You're unlikely to have seen it in school or anything like that. It's pretty cool, though. I like... this is 1A. Oh, okay. It's pretty cool, though. I like that it has these, like, extra... Implied. Okay. I like that it has these extra sort of... TXS. Safety features. Like, you can express it more in... You can express more things in terms of the type system in Rust than you can in most other languages. And so it's easy to like make it impossible to represent an invalid state, which makes your programs safer. Yeah, I haven't just been doing C and Java. Yeah, I was just talking about how I also did a lot of Java in school and have never seen it since. 1A, 3, 5, 7, D, F. 570F. 1, 3, 5, 5, 7, D, F. 3, 5, 7, D, F. Interesting. I'll have to look into it. Probably more unique to stuff, this type of stuff, though, right? I mean, it's not unique. The main things that I know of that use Rust are like Mozilla projects. So like the new Firefox rendering engine uses a lot of Rust. They're really like the main corporate backer of the project. Anything that you want to do that is like systems-y. So like if you wanted to write a database, I would say that Rust would be a good choice for that. If you wanted to write a game, I would say that Rust is getting to the point of being good for that, although it's probably not quite there yet. If you want to write like a web page, a web app, you probably shouldn't use Rust, although it does have some facilities for that. Anything that needs to be kind of close to the metal, have very high performance, not have a lot of abstraction kind of like getting in the way, that's the kind of stuff where Rust will really shine. No op 89, that's going to be, whatchamacallit? What am I trying to say? Immediate. Okay. So many no ops. I think all I need to do here is step PC. Is that a real opcode or did I make that up? Instruction 1C, that looks correct. All right, dope. I'm in a class right now using Java and I'm starting to run out of projects to do. You mean in Java or outside of Java? Hopefully I can get some inspiration by watching. Yeah, if you are interested in emulators, there is a really good emulation Discord. I posted the link up above in the stream chat, but I can drop it again, I guess. So if you're interested, I would highly recommend that you join us there. I gotta set up one of those Twitch bot things, I think. All right, 1C. What's going on here? 1C. Absolute X. Okay. Abs X. Is it beginner friendly? We're relatively friendly. I try to be friendly. No, it's a pretty good community. There are some people who are jerks, but there are some people who are jerks everywhere. And we try to call them out when we see them. Three, 5, 7, D, F every single time. 7, D, F. 3, 5, 7, D, F. 3, 5, 7, D, F. Okay, and that's what I did. So this should all be fine, except then you just do micro, boom, no op. Certainly, we will never give you grief for asking beginnery questions. I'm just trying to expose myself to more computer science related things considering it's my major. Yeah, I think that's a great idea. There's so much stuff in computer science, and honestly, like, most people only scratch the surface, myself included. One of my other projects that I've sort of put on hold for this challenge is I'm going through and implementing a bunch of like old CS papers from the 70s and the like, and just kind of like checking stuff out, seeing the things that have been known for a long time that nobody really does, and so on and so forth. Something strange happened here. It's possible everything's fine, but it doesn't really look fine. going on exactly? Is there an opcode 0? Because I'm pretty sure there's not. Actually, I can just look at this, huh? 0000 is break. And I don't think break is tested in here because that would be kind of weird. So what did I do wrong? I think I'm at 7FAB, which is not a real instruction. How about C884? That is one. I apparently RTS'd off the end of the map somehow. But before that, we were at C87D, which does seem correct. But how did I get here? That's a great idea. The past always has good information hiding. Yeah, absolutely. A lot of people, for some reason, seem reluctant to learn from history. I must have done something wrong. What's going on here? C85E, I guess. This is like way back at the beginning. Did it loop? Alright, I joined the Discord. Welcome aboard. Okay, so the last no-op that I implemented, I think, was this one here at C701. So let's scroll up and see when we were kind of in that area. I know I have a problem with flags, so maybe that finally bit me. I've been waiting for it to for a long time. Okay. Instruction FC, and then we should go munch and get EA at 704, which we did. 705, 706, 7, 8, 9 is, wait, oh yeah, 8 is push, 9 is pop, A. Okay, when's the next, like, branch? I guess would be C718? Okay, so where was I? C713. And then we get C71B, which we're not supposed to. Oh, no, we are. PLA. 720. Are you on a specific channel? I'm basically all over. The NES channel is a good one for discussing the NES, I guess. I don't know where I thought I was going to go with that sentence, but yeah, I kind of lurk in all the channels. 2A, 70C, is that what I'm supposed to get? Oh! Okay, so from 2A, we go to C80C, which is not right. How did that happen? What's the opcode at C7? 2A. Hello, cat. Oh, I bet I didn't wrap correctly and branch clear. Do. Hello. Chip Vader NES Emulator is a great project. Yeah, I agree. Tangled up. Hello, cat. You gonna step on my lap? This is my cat. One of them. I have two. He's the photogenic one. They like to show up periodically to bother me. Although usually they don't bug me too much in when I'm streaming because they don't like it when I talk to people they can't see. It's okay, buddy. Alright, back to work. I don't think I've ever seen that one. Yeah, he's the fluffy one. His name is Faint. They are both named after Linkin Park. Meteora is the other one, which is an album. Faint is a song. Are they both neutered? Yes. Kitty break. Yep. Okay, so what's going on here? We're branching wrong. And so we fetch IDL. I always forget you can't see me pointing. And then we execute branch clear. And we take the branch. So we do enter this. But then we somehow end up adding an extra 1 to PCH. Which is right here. Where we shouldn't, I guess. What is this instruction? This is D0. If the 0 flag is clear, then add the relative displacement to the program counter to cause a branch to a new location. Okay. Relative addressing is what we're looking for here. Cat, stop. What are you? He wants to eat cords. We've got 2 cats at my house and 1 isn't. She can meow like a son of a... One isn't a good cat? Or isn't at your house? Isn't what? Hey, stop that. Oh, there you go. You kicked the ball over there. That's what's up. Alright, hang on. I have to throw this ball for my cat. So that he will stop being weird. Alright, you ready? Go get it. Okay. Oh, is it neutered? Yeah. Branch not equal. Cat's playing fetch. He doesn't so much play fetch as he does chase a ball around and batter it around the floor. Fix PCH. If it did not change, increment PC. What is going on here? Okay, so we were at 7-2A, right? And then we're going to add E0. So that does roll over. But for some reason, rolling over, we get it twice. If temp PC and F is not equal to 0, so if it's greater than 255, you set this, and then you set that, and then there's a no-op. Why would I not be adding PCH? Like, I should definitely be adding PCH. Or adding 2 PCH, rather. So I already did that for some reason? BNE. All we've done is fetch to the IDL, which we add right here. Alright, let's just print a bunch of stuff then. Branch clear, :sharp X, or status, :sharp X, PC, :sharp X, IDL, :sharp X, CPU.regs.p, CPU.getPC, CPU.idl. And then branch taken. Catch fish for themselves until their instincts run out and they realize the ball isn't alive. Yeah, pretty much. They just kind of play with it until it fails to try to escape them. I got them this little motorized mouse toy. Oh man, they love that thing. But either the battery ran out or it has like a firmware bug or something because it's not really working anymore, unfortunately. Temp PC. New PC. Get PC. Alright, let's see what we get from this. Where was I again? C72A. So way up. Here we go. C72A. D0. Okay. Branch clear. Status 7C. PC C72C. We are supposed to take this branch. IDL is E0, which is correct. Branch is taken. The temporary PC is 10C. Right? And then the new PC becomes C80C. I don't understand. I mean, I guess I could just remove the fix, but it doesn't seem like it should be. It's very annoying. Does this say anything interesting about this? Assigned 8-bit relative offset. I wonder if that's the problem. Because I'm not adding it as though it were signed. And E0 is actually negative. I bet that's the issue. Yep. That makes a little sense to me. As I8, as I16, as U16. Wait, no. As I8, as I16. Do. And then this is PCL as I8 as I16. That should work. Oh, literal is out of range for an I16. That's dumb. As U16. I somehow feel like I'm not even going to get as far as I did before. Oh, no, I still end up at the same place. Coming from C72A. La 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 la. Okay. Wait, what? Why I8, I16 there instead of U stars? Because the relative addressing mode has a signed 8-bit relative offset, which is added to the program counter. And then when I do the as U16 thing here, I lose the signedness because it doesn't sign extend. So maybe what I should be doing actually is one of the weirder adding modes in Rust. So Rust U8. There's like an add, like an overflowing add that will also give you whether an overflow occurred. Yeah, okay, let's do that instead. All right. temp PCL overflow equals PCL dot wrapping add IDL. Right? And then here we will do if overflow, and this should just be temp PCL, which should happen either way, honestly. It does. Okay, let's see if that works. Nope. So I didn't change this. Expected U8 found tuple because I used the wrong format, overflowing, not wrapping. Go. I bet there's a lot of places I could have used that and it would have made things clearer. Man, come on, what's going on here? C7-2A, so this is where we were screwing up before, and we're still ending up at the wrong spot. What the hell? IDL is still a U8. Does it matter? Alright, Ewago, I'm going to look and try and get some rest. Got work tomorrow. Take it easy. Yeah, you too. Thanks for stopping by. I really appreciate it. Am I even supposed to be here? Like, what's going on? I'm very confused. I guess this is the bit after that for some reason. For 2's complement math, it shouldn't matter whether it's a negative or not, right? The addition should just be the same. But, like, it did overflow. Alright, what number is E0? Negative 32. Okay. Plus 2A gives us A. Oh, but it increments first, so plus 2B, I guess. 2C? Yeah, 2C. 2C plus E0 gives you C, which is correct. It also gives you an overflow. Except maybe it's more like an underflow. Because if you were at, let's go to words, C7 to A, and then you were going to add E0 to that. Oops. Oh, well, so see, this stretched it, and you end up with C7OA. Yeah, I think I'm just doing the sign stuff wrong. Let me try this again. Let sext add equal CPU.idl as I8 as I16. Implementing unofficial ops. Well, I was, but then I started failing on a branch where I was adding the relative address as unsigned, and it turns out that it's signed. And so I hit my first negative branch, I guess, and it went all screwy. And I flew off the end of the world and started executing invalid instructions. I think, anyway, that's what I assume happened. And then let cur PC equal CPU.getPC. Yes, branches are signed. Yeah, I figured. I didn't figure. I don't know why I said that. Alright, let's signed PCL equal CPU.regs.pcl as I8. Maybe I just need this as I8. Alright, and then if I did this with signed PCL overflowing add with sex add, then maybe I would get it. Because it's not actually overflowing if you do a signed add. Imagine a world without signed branching. Yeah. Expected U8 found I8, so as U8. And again, as U8. Overflowed. No overflow. I was working with Rust at a low level like this. I got really frustrated working with C strings and pointers. Not sure how much of that is applicable to your project, but I see a lot of casts. It's not too bad, honestly. I don't think. E543. What the what? Oh, okay. Yeah, I made it to the right spot. That's good. Okay, I fixed it. I gotta fix the other half. It's not too frustrating. You have to cast a bunch to go from like I8 to U8. The real places where I'm casting that you wouldn't have to in C is because I used enums and then I had to turn them into numbers again. There's a lot of ways that I could have not done that. This is not at all like enormously well-designed code because I'm trying to do it under time pressure and I'm not going back and like making the changes that I might otherwise. Like if you look at this, these are my micro operations, and there's like, I don't know, 32 or so of them. Oh, even more. There's a lot of them, like 50, and you probably need like 20 if you had a good implementation. But I didn't figure out what a good implementation looked like until I was pretty deep into it, so oh well. Doing FFI stuff, added frustration of needing an API. Yeah, I mean, anything that's going to be CFFI is going to be tricky because C is not Rust, very aggressively not Rust, and if you try to do the things in Rust the way that you would have done them in C, it will be bad for you. It's sufficiently challenging to get CFFI right that I spent like 2 hours arguing with Eddie B one time about whether a certain implementation was correct because valid instruction A7. Wait, what? Uh-oh, that doesn't seem right. About whether a particular implementation was right because it turned out that we were just thinking of different ownership models for the strings. What did I do that broke everything? E598. Okay, I mean, that is right, but we shouldn't have gotten there because I didn't implement lax. So what happens? E47B? That's not correct. What happened before that? I definitely broke a branch somewhere. Where are the C's? FA28. Yeah, this doesn't look right at all. XAA when? Pretty soon. What dumb shit did I just do? Okay, this is correct. I should commit code, and I should also push it to my GitHub because I said like 4 weeks ago I was going to do that. And by weeks, I mean days. NES test doesn't test XAA. Okay, well then, doesn't it? That's surprising. L. L. Everything else should be exactly the same. The only difference is that this is clear and not set. Everything else should be identical. You can't test XAA, it's an incredibly unstable op. X and A and immediate or magic. My favorite. What the hell? By fixing my branch, I break my branch. This is very annoying. So I was previously doing an unsigned branch. And it was getting to the correct location. So what the hell? Alright, here's what we're going to do. We're going to bring all this junk back. We're going to copy it up to branch set. Do-do-do. 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 Oh, oops, this is supposed to be no overflow. Oh, hey, hello again. Hi, Silverblaze. I wasn't going to stream today, but some plans changed. How's it going? Not too bad. Life just falling apart at the seams. The normal stuff. Yeah, I'm sorry to hear that, although I do relate to it. C7-2F. Okay. It's like the very first thing. And it's supposed to decide to go to C7-3F5, which it does. Okay. So that was correct. Was there no overflow? No, there was no overflow. All right, let's assume that the problem only occurs when there is overflow. Which may or may not be true, but whatever. This is going to be so dumb when I find out what it is. Okay, so this is DD7D. Branch equal, and it ends up at DE83, which is wrong. DD7F branch is taken, temp PCL is 83, which is correct. But then we end up with DE83. And why does that happen? Looks like your code is giving you the wrong D. Indeed it is. So what is happening here is that we're adding 4 to (7E). Oh my god. It thinks it's overflowing because it's overflowing a signed integer. A signed U8 is overflowing. But it's actually an unsigned U8. The overflow is not actually what I want to check for. Jeez. Alright. This is so stupid. This really just shouldn't be hard at all, but for some reason I'm screwing it up pretty bad. What's the right thing to do here? I mean, I could... I felt that, oh my god. Yeah, I told you it was going to be dumb once I figured it out, and it is. Okay, so if I 0 extend PCL and I sign extend the offset, and then I add them together as signed, then if I get negative overflow, which is not overflow, but then I will detect that correctly. And if I get positive overflow, I will also be right about that. So I could do that, or I could just compare things directly, which is probably a better, I don't know. I don't know if that's better or not. I need to like write some shit down or do some math in a calculator just to make sure that I'm not being dumb again. Okay, so cat, please stop eating cords. All right, so 7F. That's a big calculator. Hey, I'm a streamer now. I got to make everything huge so people can read it. Right, so we're at 7F, and then we're going to add all right, so if you 0, 0, 0, 7F, we add 4, obviously that's fine. If we have add 14, or no, 7F, we add 84, then that'll be set. This calculator has saved me a lot of time. So good. Yeah, it's really good. I am pleased that they added all the programmery stuff. It's super helpful. If I wanted to do 7F plus like negative 32, or no, hang on. 7F, crying out loud. 7F plus FFFE, which is negative 2. 7D, which is fine. 7F plus 8,000, which is negative 32 bajillion. The high bit will be set. Okay. Here's what we're going to do. Let Zext PCL equal CPU.regs.pcl as U16 as I16. Let Sext add we've already got as I8 as I16. Alright? And then we're going to do let temp PCL equal Zext PCL dot wrapping add Sext add. If temp PCL is less than 0, then we underflowed and we subtract 1 from PCH. Does your code actually sext? Alright. And then, else, if temp PCL is greater than FF, then we do this. And that should work. Why is everything blue? That's worrisome. Just bad syntax highlighting, I hope. Yep. Okay. What's amazing? And I'm just gonna literally copy this whole thing. Paste it right here. Frag all this. And hope that that's good. And by hope I mean test it, obviously. Okay, well, I ended up where I expected to add, but I expected to assert false a couple of times and didn't do that, so that's troubling. Alright, if I literally hit any branch ever, it should die. Okay, so it did. Branch taken, no overflow, C735. Okay, so that's the very first branch ever, which is this one. That was branch set, branch taken, wait, no, branch clear. Hang on, what? Oh, I didn't change the name. My bad. Okay, that was branch set, no overflow. So we'll delete that and move on to the next thing. Okay, well that's obviously somebody somewhere is doing it wrong, even though that's exactly where I expected it to eventually end up. There's no way that it doesn't test branch overflow, so I'm kind of confused. What's the next branch? So we got BCS, and then we get another BCS, which is C737. So there's C735, here's C737. And we don't take the branch. C742 don't take. BCC don't take, or do we? Yeah, we do take BCC. So C740 is the next one. 4D. Do take branch, no overflow. I guess, okay, that's fine. Maybe this is okay? It doesn't seem like it's okay, though. It's very troubling. But I guess it's fine. I mean, I ended up where I wanted to end up. I really should print this in the format that this thing outputs, but I don't have PPUs, so that would be challenging. I'd have to like do some massaging, which would honestly not be that bad. Where am I? So E545 gives us LAX as the opcode. Alright, you know what? I think I'm just gonna be done. I don't need to implement these opcodes, I don't think, for SMB3. So I think this is a good enough CPU to complete my current objective, and any further would be sort of embellishing beyond the point of being strictly necessary. So that means that I'm going to be done for today, I think. And we will go back. We will come back tomorrow, fresh-faced, bright-eyed, bushy-tailed, and implement the PPU. Everyone, I want to thank you one more time for coming by. It really is great that you feel that this stream is worth your time, and I just really appreciate that. Feel free to stop by tomorrow and Sunday. I'm going to do at least 8 hours of streaming total over the weekend, probably in several chunks. Don't give up getting audio in the 2 weeks. I won't. I'm going to try and do that. The PPU is basically going to be either extremely straightforward or extremely difficult, and it's like much less functionality than the CPU, but it's much more complicated and easier to get wrong. And as you can see, I got plenty wrong in the CPU. So it'll either go really fast or it won't, and then we'll see about audio. Thanks, Silver. I look forward to seeing you again. Good night, everybody.